So the next few problems I'm going to do are all involving parallel lines and angles that come up with parallel lines. So the first thing I'm going to do is go over kind of the strategy that we're going to employ. And the idea with parallel lines is that any two angles that show up have to either be the same or they have to add up to 180. So I'll give you an example of how to apply this. Let's say we knew that the angle in the lower right was 95 degrees. Now I picked 95 because hopefully it's obvious that this angle is a little bit bigger than 90. And then we were asked, well, what is this angle? We can look at the angle in the upper right and just visually we see that it is acute, whereas the 95-degree angle is obtuse. That means those two angles are not equal. In other words, they must add up to 180. That allows us to label this angle as 85. Now we can go through and label every single angle in the picture, because vertical angles, angles that are directly across from each other, are always equal. So I just labeled vertical angles. And then of course angles that are side by side on a particular line add up to 180. And so like this 95 and this 85 add up to 180. Let's look at the other picture. Let's say that we knew that this angle was 80. What could we deduce? We could deduce that this angle was 80. And now what am I really illustrating here? I'm illustrating that even in a complicated picture, we can narrow our focus to some piece of it and apply the previous reasoning. What I can't do in this example is look at this angle that I've just marked in red and say, well, that angle that I've marked in red has to either be equal to 80 or it has to add to 180 to give 180. And that doesn't work, because the angle that I marked here in red does not arise from a pair of parallel lines cut by what's known as a transversal. This thing right here is called a transversal. And then this line and this line would be parallel lines. Again, when we have a complicated picture like this one, we can perform the same amount of reasoning, but what we've got to do is we've got to identify clearly which pairs of lines we would talk about as being parallel versus the line that's a transversal. That would be another example. We could treat this line in orange and this line in orange as being parallel. That gives us a possible transversal here, a possible transversal here, and what might be a little bit hard to see, we could get a transversal there. Okay, enough with the concepts, let's get on to some problems. Alright, so right away in this first problem, we've got a picture that is slightly more complicated than your basic everyday parallel lines setup. Specifically, what we have are a couple of parallel lines, L and M, but they're cut by two different transversals. There's one of them, and there's the other one. So, we got a math question with words in it. First thing we do always is we read the end. Which of the following must equal 180? And of course that really doesn't gain us much, but it's a good habit to get into. Looking at the answers, you probably struck right away with the observation that none of them are just a pair of two numbers that add to 180, which was what I just spent some amount of time teaching you, was to figure out two angles that either add to 180 or are equal. And none of them are k plus n plus p. K plus n plus p would be really convenient because that definitely adds up to 180 because it's the three angles in a triangle. What are we going to do here? My best suggestion for this is to make the observation that all of the answers are variables, which means we can pick numbers for the variables and then test the answers using those numbers. The first thing we have to do, though, is a little bit of what I call angle chasing, where we label the picture. So let's zoom on in here, and what's a good number for k? Let's do 50, 60, and 70 for k, n, and p. That's my personal suggestion for random three angles of a triangle, 50, 60, and 70. Now, let's use our powers of parallel lines-ness that we learned previously. If we look at this line and this line, L and M is being parallel and cut by this transversal, that tells us that this angle is 50. Same reasoning, except for using this line as a transversal, tells us that this angle is 60. Now it's not a big deal to label the rest of the angles because that makes this one 50 and this one 60. Vertical angles are always the ones that I try to label right away if they come up because they're the easiest. Now, let's look at the answers. K plus N plus R. K plus N plus R. 50 plus 60 plus 50 is 160. K plus P plus S. K plus P plus S. We have what potentially could be a winner, but we have to be careful. K plus P plus S adds up to 180. N plus P plus S. So I'm looking at this one. First I did K plus N plus R. K plus N plus R was 160. K plus P plus S, K, P, and S was 180. So this one, we're going to circle it if none of the other ones come out to be 180. If one of the other ones does come out to be 180, we got to go back and pick some different numbers. N plus P plus S. N, P, and S. 60, 60, and 70 is 190. N, P, and T. 60, 70, and 60 is 190. And R, S, and T. R, S, T, 60, 60, and 50 is 170. So, sure enough, K, P, and S. Now, of course, that's one way to do this problem. which is not good enough for us. We've got to come up with another way also. And I think the easiest way to see abstractly that K, P, and S add up to 180 is that S is the same as N, because the angle in the upper left and the angle in the lower right are the same according to L and M cut by this transversal. So that's one way to see that B is the answer without plugging in numbers. We didn't actually have to have numbers for that. We just know that this angle K, P, and N add up. K plus P plus N is 180, because those are three angles in a triangle, and then we know that N equals S, because they are corresponding angles with these parallel lines. Ready for the next problem. So a little bit simpler picture here. However, this picture is drawn to create the illusion that the transversal is hitting at a 90-degree angle, which won't let us do that whole acute obtuse level of analysis. So I'm going to show you how to get past that. Anyway, the question in the figure above, if L is parallel to M and R equals 91, then T plus U equals. So R is 91 here. That means R is obtuse. So it might be more helpful if we go ahead and exaggerate the picture. Now we see that if R is 91, T is certainly not equal to R, which means T has to be 89. And T and U equal each other. T plus U is 89 plus 89. 89 plus 89 is 178. What's another way we could do this? Well, we could also see right away that S is 89, because we have 91, and then we have a straight line that's 180. 91 and 89 add up to 180. Now, I'm going to have to resort to disgusting school words for these angles. S and U are what are known as corresponding angles, which means they're equal. And that tells us that U is 89. And, of course, 89 is also what T equals. 89 plus 89 is 178. Not really entirely different methods, but I certainly wanted to illustrate how you can avoid their trickiness when they don't want to make it obvious to you which one's acute and which one's obtuse. Okay, in this last problem, we have a parallelogram, and I want to point out to you that anytime you have a parallelogram, we can view the horizontal lines as being parallel, and they're cut by either of the lines that are not horizontal as a transversal. Alternatively, we can think about the orange lines as being parallel, and they're cut by transversals, depending on what we're asked. In this particular problem, it's going to be useful to treat the blue lines as the parallel lines and the orange line as the transversal. On to the problem. We've got a parallelogram. If x is 300, what is the value of y? So, just like the fact that when we have a line, this is 180. When we have a full circle, we have 360. So if part ways around is 300, then what's left is 60. Now, this angle in yellow is either equal to or adds up to 60 to be 180 with, I said that weird. The yellow angle is either equal to 60 or it adds up to 180, adds up to 60 and gives 180. It's obviously not equal to 60 because it's obtuse. That means this thing is 120. If this portion is 120, what's left has to add up with 120 to give 240. And, I'm sorry, I skipped the answer. It has to add up 120 plus the mystery value y has to be 360. That means the mystery value y has to be 240. Let's see if we could chase these angles in a different way. So I'm just going to redraw the picture. We could take the observation that this is 300 and deduce, because this is 180, that makes this 120. And that would make this angle 120. Likewise, we can say that, well, now this angle is 60 because 60 and 120 add up to 180, and this is a straight line. That makes this angle equal to 60 and this angle equal to 60 because both this angle and this angle equal this angle. Now I said a lot of this angle, blah, blah, blah. So I'm going to trace back through that with the pointer. The entirety of the upper right was 300. The portion in red was 180. That means the portion in orange has to add to 180 to give 300. That means the portion in orange is 120. Using this transversal and these parallel lines, we can deduce that this angle is 120. The angle in the lower right. Now, the blue angle plus 120 has to be 180 because together they form a line. That means this blue angle has to be 60, which has to be the same as this angle, this blue angle, and this blue angle. Finally, 60 plus 60 plus 120 is 240. And there you have it, 2 different ways to do the problem.